Hey, this is Steven from LegitTechTutorials, and welcome to my new season of my product design series. We're going to be talking about a new electronics project that I'm very excited for because it's in one of my favorite hobbies. And so if you guys aren't familiar with my product design series, it is a development blog style series where I design this entire product slash project in 30-minute video segments, almost entirely, 95% in the video, in the 30-minute video segments, and this series is designed for makers and also aspiring makers to get inspiration from, to go out and try to start designing projects, and to be to gain the confidence to continue going in the project until you complete the project. So you'll see in this video is very raw. You'll see mistakes, you'll see missteps on my part, and you'll see me come up with solutions and continue grinding until I get to the end of the project. So you'll see a lot of different things. There's going to be a lot of different disciplines in this particular one. We're going to have PCB design, open source programming, Arduino programming, phone apps using Wi-Fi or Bluetooth protocols, plane design, RC plane design, because this is an RC plane project, and some other things like that. Soldering, electronic basics. So electronics, PCB design, app design, and wireless control of electronics using your phone, and RC planes, stuff like that. So physical design. So we're going to have physical design, PCB design, electronics, soldering, electronics basics, and also app design. It's pretty much entirely what I've been doing throughout this entire channel of LegitTechTutorials, which is physical design, electronics design, PCB design, and game design, but similar to app design. So very multidisciplinary project, and yeah, so you'll see all that done in this development product design season, and yeah, just be on the lookout for each of the videos of this season. All right, so this project is for an RC fixed wing aircraft. Now, it is a phone-controlled micro RC receiver. So phone-controlled meaning Wi-Fi or Bluetooth-controlled receiver that you could control an RC plane with. So me and my dad are very big into RC plane hobby, and there's like 6 different segments that I think people get into as they evolve and grow inside the hobby. One is they get to larger models where they get bigger. The models get bigger until you're doing 8-foot models, 10-foot models, giant 747 models, scale. So basically, you get more and more into the scale of the bigger scale of the planes. Then the second one is you get smaller scale. So smaller, all the way down to 2-inch wingspan, 4-inch wingspan, 8-inch wingspan, 6-inch, 10-inch, whatever. Start to get smaller and smaller on the wingspan. Number 3 is you get faster planes, faster until next thing you know you're over 100 miles an hour, and even higher than 100 miles an hour. And the next one is you get into more aerobatic flight, so things like 3D flying, doing flips and close to the ground, and high power to weight ratio, and doing 3D flying with fixed wing aircraft. Then we have the last one I call kind of like a utility, such as FPV planes, UAV, autonomous aerial vehicles, so doing stuff like 3D scanning buildings, or surveillance, or whatever. That's more of the utility side. So this project is more towards the second one, which is smaller scale flight. So when you start to drop the scale down on the planes, that's when this guy is going to come in. So now this is for very small planes, fixed wing aircraft. Of course, this is not really built for quadcopters or helicopters, which I guess you could use for helicopters. I guess that would work, but not really for quads. You could probably make it work for any of those. So this is basically for phone Wi-Fi / Bluetooth controlled RC planes. Now, I'm going to be mainly designing it for fixed wing aircraft, something between 20 inches, less than 16 inches of wingspan, down to, you know, ideally around 6 to 12 inches, and then at 14, 15 inches you're starting to get to where you probably need full-size standard receivers and stuff. That being said, this is ideally designed for small aircraft, and I'll show you guys a few examples of that. Now, the main design of this module is to lower down the price of entry into RC planes for beginners, and even for people that do fly a lot but just don't have to carry around much equipment. So generally in RC planes, you have a few different electronics that are required to get a plane to fly. You have the receiver, you have the, so this is in the plane. You have a motor, which is common throughout all airplanes, because you're going to need, or any sort of RC aircraft, you're going to need a motor, so we're going to discount that. Then you have the receiver, so you have the motor and then the battery. Both are common throughout any sort of design, you're going to need that. Then you have the, and those generally don't change if you change these other things that I'm going to talk about. These are independent of these other choices. Then you have the receiver, which goes along with the transmitter. So you have a transmitter receiver. The transmitter is what the pilot interacts with that sends information to the receiver, and then the receiver controls all the electronics in the plane to control the plane. So you have a transmitter receiver. Then you have the servos, which control the control surfaces to move the plane around, and obviously in quadcopters don't have that. They have 4 motors, or 6 motors, or 8 motors, or whatever, but quads have 4. Then you have the ESC, and the ESC is called is the acronym's electronic speed controller, and that's what controls the throttle of the motor. So the main 3 electronics are the servos, or what controls the control surface. Then you have the ESC, and then you have the and then you have the receiver, and then you have the transmitter, right? So what we're trying to eliminate is, with the phone control, you eliminate the transmitter. You use the phone, which a lot of the population on Earth now have a smartphone. And also you want to combine the ESC and the receiver all into one unit. So now they're all combined. And now there are some on the market that are larger, slightly larger aircraft, which are called 3-in-1s, or all-in-one bricks. So they have the ESC, the servos, and the receiver all built into one. That is called the AR6400, something like this. This was originally designed by not Spectrum, but by Hobby Zone. Or actually, it's a Spectrum. It is a Spectrum receiver. It's a Spectrum receiver. So as you see here, we have the ESC, we have the servos, and then built into this we have the receiver. So that's all built into one. But on our particular design, starting out, so it could be to this point, but right now, starting out, we're going to have the ESC and receiver combined into one, and then the control surface will be elsewhere. So what I've really been getting into is I built a smaller plane that uses what's called the two-channel control, throttle and rudder, and that's kind of all you need to control a fixed-wing aircraft, is throttle and rudder control. And that is from a company called Flyline RC, and it was a small plane. I think it's about 12 inches, 12 to 13 inches in wingspan. Maybe they have... Okay, maybe it's 20. Oh, just disregard that. I'm encoding a video right now. So I think this is 12. Like I said, 12 to 14 inches, something like that. Anyways, basically what this was originally designed was to spin around a pole, And so you have throttle and elevator control, and here's what the plane looks like. You have throttle and elevator control, and I basically took the elevator control and made it rudder control. So now it's allowed to fly without the pole, and here's the pole. So I really enjoyed this plane because I still have it, I still fly it quite a bit. Because you could fly it around any sort of small park very slowly, and yet it still looks like a P-51 Mustang, extremely cool. So I was like, okay, can you go smaller? So I started investigating smaller, and then I found out the price of entry. So this is from a company called Plantraco, and it's www.microflight.com, and I believe this company is starting to go underwater because of the price of the planes. Anyways, basically these are very, very small planes. These are 1/48 semi-scale, and they have, most of these have a 10-inch wingspan, and they're made out of small white Depron. Extremely light. I believe this one, so yeah, 9x9 by 2.5. It weighs in less than a sheet of paper at 4 grams. So it's extremely light, but it's really small. You guys could look at some videos. I forgot to grab a video for it, but extremely small to fly, and very, very cool, very responsive. I might just look it up right now. Here it is. So yeah, something like this. So I'll talk while the video is playing. So something that's this small, they use extremely small receivers and ESCs built in to one piece. So that is basically what I'm trying to accomplish, is to kind of copy this, but instead of using the transmitter, use your phone. So you lower the price of entry quite a bit. And what you'll find is that and you see it's about the size of your hand. That particular transmitter is $60 for the transmitter. And that transmitter has a port in it for the battery connector, as well as to charge the batteries, and also it also has all the gimbals and stuff in it to transmit to the receiver on the plane. The receiver itself on the plane is extremely light, very cool receiver. It controls what's called a linear actuator on the back of the plane, which I'll show you guys in a second. And that guy is $15 for itself. So right there you have $75. So in this design here, I'm trying to eliminate the controller, so that right there eliminates $60 in the design. And then I'm trying to drop the price of the receiver from $15 to around $6, right, in half, $7.50. So that's why I'm trying to drop the selling price of that. So immediately get rid of $60, get rid of the $60 for the controller, and get rid of the extra 15, so down to $7.50. So you go from $75 to $7.50, like quite a bit of savings. Like $75, so that's half. I mean, that's a tenth. You drop the price by a tenth. So altogether, I want the plane to be able to fly for $15. Plane ready to go, in your hand, flying for $15. Now, when I bought this company, Flyline, was liquidated back in 2013, and I bought it for $20. So I'm able to get a plane that flies around a field for, I have 3 batteries for it, for 3 batteries for a total of 20 minutes, right? Really small, really nice, slow-flying plane, fly it in a small field. But these guys, you know, you could fly them around, it says here 20 foot, a 20 foot by 20 foot room. So you could so of course I wouldn't want to say this, but you could fly it around work, possibly inside of your break room when you're out on for a break, or you could go. Sometimes you'll even see videos of these guys flying outside. So they'll fly outside. so you can fly them outside and be able to get really small flights in small areas. So you could fly it in your front yard. I can't fly this in my front yard. It's too big and flies too fast. So that is the idea. So again, $60 for this, and I'll show you guys those transmitter and flight packs very quickly. Actually, let's just show you guys oh, it's down here at the bottom. Here's $60 for the transmitter, and then you have the receiver, $15 for the receiver. So now, like I was saying, and that's what adds to this crazy number of $130 for a plane. So instead of $130, I really like to be $14, $15, right? And these guys use what's really cool, it's called a linear actuator on the tail. This one doesn't show it very well. This one showed it. Where was it? Here's this one. Yeah. So this is a slightly bigger plane, but this shows it right there. You can see the linear actuator. And basically what that is a winding of copper wire, and you stick a magnet in there, and then you attach the rudder to it, and it will allow you to get dynamic control. And then even something like this guy here. This guy here, it's a either Japanese or Chinese video, and I like to watch a lot of these because they build these things. Basically, what this guy builds it out of is he builds it out of really cool. It's a piece of packing foam, and he builds a hot wire, just cuts a piece of the packing foam off, and then so you'll see here he just like slides the packing foam over this hot wire and creates these small sheets. And he builds the entire plane out of this small sheet of I'm going to assume that this is expanded polystyrene, similar to Depron. And then he cuts out this plane, and then he uses the actuator there, as you saw. And there's the actuator moving, and then it applies a motor to it. So he builds that for really cheap. But I'll show you how the electronics are what is holding him back. So he builds most of that plane for cheap. Like that motor there is about a $2 motor. The plane itself was completely free, but the issue is this particular piece that he uses. These two pieces. So here, this is an E-Flight MLP 4D5M. So this particular controller is what's called a DSM-2, where you see it here, DSM-2 technology. It's a spectrum protocol, a transmitter protocol that transmits to specific receivers. Now, I believe that the reason why these receivers are why these transmitters and receivers are so expensive is because they are because they're using a proprietary protocol that is restrictive as far as the cost. So I'm going to guess that they're licensing it. When they license it, they have to pay a specific cost to use Spectrum's protocol. While Wi-Fi and Bluetooth, not so much. So this guy right here, you could find them for about $50 retail, or you could find some people getting rid of theirs, like doing some sort of, there was a listing in here for like a bid. Sometimes, generally you could get them for about 20 bucks, but sometimes they're hard to find. So right there, that's 20 bucks. So 20 bucks, and then what he's using is a Deltrang receiver, a Deltang or Deltrang, I forget. These are very popular on these size of aircraft. So on most of the videos that you find of these that are Chinese or Japanese, I don't know, they're probably Chinese, where you see a lot of these small microplanes, generally they use this transmitter. This receiver, which is the Deltrang receivers, but these are not much better. As you see something like this, where it has physically the same as above, but it has a FET installed for the motor ESC. The thing is that I think the one that he's referring to, the RX-42, is no longer on here. So I think that's no longer selling. They have the 43 and the 41, but they do not have the 42. Anyways, so 31 euros, which is $33. So a $33 receiver and a $50 transmitter. So that's already $50. That's higher. That's better than the other one. So that is, it's gone down from 75 down to down to 50. So that's a little bit better, but still not nearly as good. So most of those videos that you see, they're using this guy. So what I'm planning on using, so now most of the video, the first 15 minutes, first 20 minutes were what the, where in the market this fills, what I'm trying to fix, what I'm trying to solve, and then now I'm going to tell you about my solution. So again, to drop the initial price of getting in, so you can build a small plane that you can fly around your front yard or whatever. Or even up to that other size plane. It's that Flyline RC, this would certainly work on that as well. This guy right here. I'll maybe show you guys some of that plane later on. Anyways, in a future video. So my solution is using what's called either Wi-Fi or Bluetooth. This is a Wi-Fi option because it's slightly more accessible. I know a little bit more about it. So this is a microcontroller similar to an Arduino. You could run it with Arduino Core or many other different things because it's a very, very popular microcontroller. It's called the ESP8266 and it's built by a company called Expressive. And it was launched about 2 years ago, and it has since become a maker cult classic. So the maker community has picked up and run with this technology, the ESP8266. Number one being that it's a very powerful processor, very fast, 80 megahertz, built-in Wi-Fi, and also there's like 10 different board configurations. This is one of the 10. I personally have, this is the ESP01. I personally have the ESP12E, which is one that has like 3 times the pins or something like that than this one. But we're not going to use that one, we're going to use this one. This is a possible solution. So the maker community has picked it up and run with it, so now there's a huge support to this chipset, and also with a lot of support. You want to start using a product that has a lot of support, so if you get stuck, you have somebody to ask to get you unstuck. So you don't have to spend all that time and then have to change what you're using. So if I could find that for a Bluetooth, because I believe Bluetooth will be lower energy on this side, I will use that. So this guy has, as you can see, very, very low price, ESP01. It has 6 pins, built-in Wi-Fi, 1 megabyte flash with the 01S. And it is about $4.50 a piece. Now generally that's pretty high. Most of the time you can buy the chips by themselves for $2. You can buy the ESP8266 chip for about $2. And then again, like I said at the beginning, we're probably going to be building our own board, so that's a good thing to look into. So very, very cheap chipset with built-in Wi-Fi support for $2, and then obviously you have to consider the board. But to start out with, we're going to use this breakout board. But originally, as you see, it says Wi-Fi serial transceiver module. Because originally the ESP01s were designed to be a transceiver between a Arduino and Wi-Fi. So most Arduinos don't come with Wi-Fi. So if you use this guy, you could send Wi-Fi signals to the ESP8266, and then it send that it picked up from the Wi-Fi to the Arduino Uno, thus making your Arduino Uno Wi-Fi. But the thing is that the ESP8266 is way more powerful than the Arduino. The only holdback with the 01 is the pins. So in the ESP12E, it's quite a bit faster than the Arduino and has just as much or more pins. So basically, I'm going to show you guys the deal with this guy, and this is probably what we're going to go with. We might go with something different, but I highly doubt it. We'll see, because we'll compare the Wi-Fi to the Bluetooth LE or Bluetooth 4.0. So this is the pinout. We have the 6 pins, the RX, VCC, GPIO 0, reset, CHPD, GPIO2, TX, and ground. Now, as far as this particular instructables, because I'm not familiar with the ESP01, I'm a little bit more familiar with the ESP12E. So this would be this is the first time I've ever used the ESP01. Now, also I forgot to say in that last point about how it's more powerful and used as a transceiver, is that this can be used solo without the Arduino Uno. So you could use, this is a microcontroller built into one. So it's microcontroller and Wi-Fi built into one package. You do not need anything else. You could run this guy by itself. And with these 6 pins, I've seen that you could also use the TX and the RX and the GPIO0 and the GPIO2. So GPIO0 and GPIO2 can both be used for PWM and input and output, and RX and TX, I've heard, can be used for input and output, but I don't know if they could be used as PWM. So, very, very powerful chipset, and has plenty of pins for us to do what we want. So with that, if we're using 1 pin per channel, so most RC planes are denoted as far as this control by channel, which means how many different signals can you send from your receiver, how many channels of your transmitter do you need to interact with the receiver. So each channel denotes a different control. So for example, one channel could be the throttle, a second channel could be aileron, another channel could be rudder, and the last channel could be elevator. So elevator is to change your elevation, go pitch up and pitch down. Ailerons are to change your roll rate, and then rudder is to adjust your yaw, and then throttle is of course to change speed. So right there, 4 pins, 4 possibilities for pretty much most RC planes are 4 to 5 channel. 5th channel or 6 channels, 5 or 6 channels are like either retractable gear landings or flaps, right? But right here we have basically a feature RC plane and a small $2, $4 package, $4.50 package by using those 4 pins. But I believe with the linear actuators, which I showed you guys on the back of that plane, the back of this plane, right? Which is this guy. That's a linear actuator basically. It's just a coil of wire with a magnet. Yeah, so with that guy, I don't know, again, this is all new to me, so I've never used a linear actuator like that. So I believe how it works is that you send a positive polarity and it goes one direction, and then you send a negative polarity and it goes the other direction. If that's the case, we're going to have to use 2 pins, one that goes in it forwards and the other one that flips the polarity backwards. And also both pins preferably need to be PWM, because that guy, if you send it PWM, you could actually control the resolution of the rudder. So it's not all the way on, all the way off. So you have like quite a bit of resolution as far as different positions throughout, all the way left, all the way right. So you could have different positions in between. So with that being said, if it takes 2 pins, then we have like a throttle, which is 1 pin. And I'll explain how that works, how you're going to do the throttle as an ESC in a second using this board. Then you have the rudder, which would be the 2 pins, which would be the linear actuator for a smaller plane. And then you could have the last pin be like your battery. So read your battery voltage and transmit the battery voltage through Wi-Fi to your phone, so you know how much flight time you have before you kill your battery, so you can get maximum flight time. So you don't have to have a counter on your phone. It can just give you a low voltage warning and say you need to land right now, just fall out of the sky or whatever. However, if you don't use so that is just throttle and rudder. As I showed you with this, that's plenty enough to fly. This only has throttle and rudder, and it flies great. Now, if you're using servos only need 1 pin of control. So you could have the throttle, for example, the rudder, the elevator, and the ailerons. You could have a mechanism where it just takes 1 servo to do both opposite directions. So you have your throttle, rudder, elevator, and aileron full control plane with this $2. Of course, in that case, you don't have any pins to do to look at your battery. Also, with that, all the pins are going to need to do PWM in order to drive servos. So, with the throttle, how the throttle is going to work, this is going to be restricted to only brushed motors, because brushed motors actually are very easy to control. Generally with brushless ESCs, you have to look at where the stator is located inside of the motor, and then adjust the timing so that it causes the motor to spin. So you cycle magnets, you cycle electromagnets on and off in order to get the speed, and then that way the ESC controls the speed by how fast it cycles each of the magnets on and off. And also there's other options of like reversing and also stopping and holding the motor. But with brushed, inside the brush handles the timing. So all you have to do is send a PWM through, and then you can control the speed with PWM from 0 to 255 on most microcontrollers. Now, the issue with that is that the PWM has to be full load current. So most of those small brushed motors like this, I think this is like a 4 millimeter. It's like, well, this one has a gearbox, but I believe it's like a 4. Most of them that are these other ones that we'll probably be using are like 4 millimeter, or we could even use the gear. The gear motor gives you a longer flight time, but that they draw generally like 0.8 amps, but that's way too high for these pins. So what I've seen people do with that is they've just used a transistor and then feed PWM through the transistor, and then that opens and controls a gate that allows your battery current to go through away from your Arduino and go right into the motor. So you can control your motor with one of these in one 50-cent transistor, right? Theoretically speaking, I have yet to try it, but I've seen it tried, and it seems like it works with like a 50 to 95-cent transistor. So that's all we need. So possibility with linear actuators, we have maybe so we could also do another thing that you see popular with these planes is they use differential thrust. So they'll have 2 motors, one on the left wing and one on the right wing, and then we could do like an elevator. So what happens is when you power up the left motor more, it turns to the right. You power up the right motor more, it turns to the left. And that will allow us to get rid of it, so we can get rid of the battery and do 2 motors. 2 PWM motors, and then the elevator in the back. And the elevator could be linear could be a magnetic actuator, and that will take 2 pins. So right there's 4 pins for a dual motor plane that has pitch, that has turn with the motors, and up and down, and has power of 2 motors. So there's infinite different combinations with just these 4 pins that you could do different things. And of course we want to allow that to happen as many configurations as possible. So, but now we need to go back to, it needs to be controlled through the phone. Now, of course, these guys I believe are like a gram max without these pins. Without those pins that you saw on there. Because those pins are a little bit heavy. So, without it, it's about a gram itself, I believe. But I'm going to be picking up one of these pretty soon. Maybe the ESP01s, the more powerful ones. That being said, now of course we need to get into the next part, which is all this needs to be controlled through the phone. So we need to design an app for it. Yes and no. Luckily, like I said, ESP8266 has been so well received by the maker community that there are a lot of people developing different softwares for it. And one of the projects that I've been following is called the RoboRemo project. And that guy is a firmware for the ESP8266 and also other microcontrollers like Arduinos with maybe the ESP8266 as a transceiver or other things that will allow the that is basically an app that you install on your phone that will allow you to, inside the app, design your own interface with sliders and buttons and images and everything. So inside your phone you design this interface, save it, and then you could use it to connect to an 8266 with the firmware built in, and control each of your different channels with it. So for example, this is the one like a throttle and a left and right. So throttle and then rudder. So with that, you could go up and down on the slider for the throttle, and then left and right on the rudder. And then you could have something like this for your battery voltage, so you know when to land. So all you do is you install the firmware onto your ESP8266, and then you install this on your phone and connect through the app on your phone to the ESP8266. So this is probably what I'm going to start with, but we get to an issue when you have rudder and elevator control, right? Because we want sort of like we want linear control, so like we don't want all on, all off. We want to have variants of our control. So we generally only use our thumbs. So we only have 2 fingers. So generally on most controllers you have the rudder and elevator integrated, the elevator and aileron integrated into one stick, and the throttle and rudder integrated in the other stick. So the issue with this is that I believe it doesn't have any sort of like gimbal, virtual gimbal built in. So they only have sliders, and then you don't want to have like 2 sliders overlapping each other and then try to deal with that. So if we do any sort of control like that, I'm probably going to have to go and design it in Unity with one of their gimbals, with one of their gimbal designs, or even Unreal. Unreal also has a gimbal design. Also has a 2D little gimbal, so maybe even Unreal Engine for that. Anyways, but Unity has a lot more stuff where it has built-in Arduino packages where we can send stuff to the ESP. So there you go. It says it right there in the title, ESP8266. Now, for the RoboRemo project, most of the stuff that he's done is he's done RC cars and also remote IoT sensors. So here you go, ESP8266 RC car. Here you go, speed and then steering. And here's a, oh, so they do have an RC drone. Okay, so they do have an RC drone. Alright, well there you go. So to design a small plane that is kind of like this, also I forgot to say that these guys are the weight of these. Why I'm always talking about weight so much. Weight's very important for small planes. As you see, it's 4 grams, or 1/8 of an ounce. And this one's pretty heavy because it has the gearbox. So that's very light. So it weighs less than a sheet of paper. Actually, I do remember, I did talk to her. So control something like that through Wi-Fi, through a free platform. And then also, of course, I'm going to support this guy if I use this platform and add to its firmware and jump on his team and help him work on it as well if I'm going to use it. Or break off and do Arduino, not Arduino, Unity powered app that has all those options already pre-built interfaces. But we're probably going to start out with this project. Alright, so that is basically it. So using an ESP8266 from the phone, or using Bluetooth, some sort of Bluetooth microcontroller, from the phone to be able to control up to a 4-channel plane that could get really, really small and drop the price drastically. Be able to build a plane from start to finish, or even buy a plane that you could buy for 20 bucks and fly around your front yard or inside of your living room. Right? Or even bigger and bigger, maybe even up to this. I probably wouldn't go much bigger than that. So that's about like a 23-inch wingspan. I probably would max out at 20, 24. Because once you get that big, you're flying really fast and you need a lot of distance. You don't want the Wi-Fi to drop off and it to fly into a window or into somebody. So you want to have the long distance. So generally with the smaller planes, you're not flying it far away to where you can't see the orientation. Right, so that's the idea, and then of course we could expand it onto like RC helicopters or RC quads. Because if with 4 pins we can control a RC quad. Also another thing that we could do with this guy, of course, is we could have we could just use throttle and rudder, and then one of them could be like an I-squared, and then the last 2 I-squared-C to a gyro, and then we could have a gyro stabilized plane. Because generally we need gyro stabilized quads, generally. Alright, so that's basically it. 40-minute video here for the intro. In the next video we'll be going in and putting that into words as far as what we want in the in the micro RC receiver for the feature set. And so next video we'll go into the Trello and figure that out. So that being said, this video, I have so many seasons, so many projects, and school, full-time school going on. So this guy I cannot integrate into a weekly basis. So I do have another RC plane project season going on for my product design series. It was started before this one, and also I have another one that I came up with that I'm also going to start eventually. And that one, basically most of these new product design seasons that I'm coming up with are utilizing screen capture as well as physical projects. So being able to take these out, solder them, plane design, flying a plane around a park or my driveway or, inside the living room. So a lot of physical stuff involved. So generally all the videos that I've done so far, besides a few Arduino videos, have been screen capture. So right now I'm in the process of setting up my room that I'm going to be recording in. So that is being refurnished, painted and stuff like that. So that is currently under construction. So until that is up, I'm not going to do any physical stuff, any physical recording stuff. I'm only going to do screen capture. So that is also a problem for that other RC plane style project, which is called the mixed chemistry smart battery charger. That one also is getting to the point where I need to start doing physical recording, where we check electronics and do soldering and do stuff like that. So that one's actually going to come to a halt. So what I'll probably do is substitute a few videos of this guy in per week instead of that guy. And then after I get the room finished, I might alternate, because I have way too many projects going on at once. So I'm going to start to cycle these around. That being said, for this guy, I don't know if there's going to be a very stable release schedule on this, so you're just going to have to look and see when this comes out. Alright, so this has been Steven from LegitTechTutorials. In the next video we'll come up with the features. And so if you like this video, please subscribe for more videos like it in this series and our series as well. And I'll see you guys in the next phone-controlled micro RC receiver project, or any of my other ones. Thanks for watching. Take it easy. Peace.